sides of the equation. The equation that we will start with is 2 times x plus 4, is equal to a negative 5x plus 1. Now as I'm doing this, you should be following along with me in your MJ so that you have this example and you can bring in any questions that you may have. Next up, after drawing the wall, when you solve any problem, we want to make sure we follow order of operations. And in this case, we always start with getting rid of the parentheses. In the previous lesson, we learned about the distributed property, so I'm going to just distribute this 2 across to the x, so I have 2 times x, and then I'm going to have a 2 times 4. On the right side, nothing has changed, so I just need to drop it down. Negative 5x plus 1. On the left side, we can go ahead and simplify. 2x plus 8 equals a negative 5x plus 1. Now the difference here in what we've seen is that if you think back to purposes of solving equations is to try to isolate the variable on either the left side or the right side, and it really doesn't matter which one you do, but you want to get the variable by itself. In this point, you see that you have some on both sides, 2 of them over here, negative 5x's on this side. At this point in solving the equation, I do want to point out that there are multiple options to which we could try at this point. We could decide to bring the 2x over to this side, which would mean subtracting 2x. Another option, if we wanted to get our units on the same side, which we will at some point in this problem, is I would subtract 8. The third option would be to bring this negative 5 over to the other side by adding 5x. And finally, if you didn't already see that, the fourth option would be to subtract 1 to bring it over to this side. Now I typically work with the variables first, so I would even just not think about options 2 and 4 right there. We'll do the units at the end. Let's look at the variables now. I can either decide to subtract on both sides or I could add on both sides. At this point, it's really just going to be personal preference. I prefer to add, and so I'm going to get rid of my other options so they're not in our way here, and go from there. So I chose to add 5x, and remember, we're going to do it to both sides now. What that leaves me with on this left side is 7x plus 8 is equal to, now we got rid of the x's on this side and we're just left with 1. Now we can go back. This is just a two-step equation, and by showing our work, we subtract 8 from both sides, and we are left with 7x is equal to a negative 7. Final step then would be to divide by 7 on both sides. Remember, we like to write them as a fraction because you are able to leave your answer in fraction form when needed. And so I'm left with x then is equal to a negative 1. Now we're going to just do a quick check here to make sure that negative 1 does work. So I have 2 times x plus 4 is equal to, hopefully, negative 5 times x plus 1. As a reminder, when you're checking, you simply take your answer. If x is negative 1, you should be able to replace it in the equation up here, wherever you see x. So I now have 2 times negative 1 plus 4 is equal to a negative 5 times negative 1 plus 1. I hope we're doing good so far. As always, it is helpful for the wall to keep your thoughts straight even when you're doing your check. Over here, I can simplify inside. I get 3. 2 times 3 gives me 6. Whoops, I'm still red. That's okay. Right here, A negative times a negative gives me a positive, so I'm at positive 5 plus 1 is 6. So do a little fun thing like this and say, yay, we got that. Finally, there's two other equations I want to point out to you to make sure that you understand. This one actually had a solution. You will be coming up with some equations where, in fact, for example, I have x plus 4 is equal to x plus 5. Now, this is still variables on both sides. If you take a look at it, even if I were to try to subtract 4 and subtract 4 or subtract 5, you just take a step back and look at this problem, you'll see that there's no number that I could put in for x right here that would equal itself. I can't take some number, add 4, and have the same number and add 5 and have it equal to itself. I'm just going to type this one out because I think it'll be quicker. So the answer for this one becomes no solution. There's nothing that you could actually put in that would be an answer, and therefore you would actually write out, where's my circle? No solution for that problem. The final type I want to show you is, and again, that was more of a basic one. You'll see that when you start to simplify some of the other equations. This one, if I have 2x plus 3 equals, how about 2x plus 3? Now, you can start to simplify again because you have variables on both sides. But if you take a step back and notice that any number that you put in for x and any number you put in for x, let's say 10, 2 times 10 plus 3 is always going to equal 2 times 10 plus 3. Regardless whether you do a half, 0.75, whatever it's going to be, you're always going to get the same answer. And in this case, again, I'll type it for quickness. The answer would be either all solutions or any solution. And that is the official answer for that problem. So you would write these if you came up with that. So be prepared for all three types where you end up with an answer like we did in the very first problem, or you come up with no solution. There's nothing that you could put in that would actually make that true. And finally, you could have one where there's any solution or all solutions.